Hey guys, Mr. Mackey here. Happy Tuesday, and let's do the second week of, statistics. We didn't do anything yesterday. Well, we did some maths, but we didn't do statistics yesterday because it was the 100th episode, and I don't know if there's any celebrations for 101. I'll look it up. If there is, sorry guys. Now, what we're going to be looking at this week, I did mention this last week, but I said that there was another form of spread that I didn't mention, and I was going to go over it. Now, this form of spread is known as quartiles. Now, quartiles are when we find a specific quarter of a piece of data, and from that we could find the interquartile range. But we'll get to the interquartile range in a minute. I'm first going to show you how to find quartile 1, quartile 2, and quartile 3. The reason why I won't tell you how to find quartile 4 is because that's 100% and that's basically the end of the data. These are all within the data, so let's get into it. Now I have 11 numbers on here, and they're all ordered because to find these quartiles you have to have them in order from smallest to largest. So let's start by finding Q2, which is 50% in the data, which means it's slap bang in the middle. And when you do that, you cross out that, until you reach a number slap bang in the middle, which in this case is 13. So the Q2, our second quartile, is 13. Now, does that remind you of a certain thing before? That's right. Q2 is actually the median of our data. So all you have to do to find one of the quartiles is just do what you usually do when finding the median. Now, Q1 represents the first quarter of our data. Now for this, we're going to have to go to this side of our median, which is where it starts. And we do our crossing out. So we go da, 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 until we get to the number slap bang in the middle of that half of the data set. This is 25% in our data set. And that means Q1, our first quartile, is 6. Now let's find Q3. So we look at the part beyond the median, which is here. This is the second half, and we need to find our median of that half. So cross that out until we reach the middle, which is 18. Now, the reason why we use quartiles is because this shows us what a majority of the 50% of our data looks like. And from this, it's a much more nicer way to find spread because it doesn't take into account extreme values, which the median might or the mean might, and a standard deviation. This is the best way of finding the spread of data when you don't need to take into account extreme values. So, how do we find the interquartile range? Well, all you have to do is you subtract Q1 from Q3. So you take away the first quartile from the third quartile, because then you know how spread out that within quartile range is. Range, does that remind you of anything? The biggest number take away the smallest. So in this case, the interquartile range, biggest quartile and the smallest quartile, take them away. So what is 18 take away 6? That gets us 12. So our interquartile range is 12. Quite a reasonable spread there, and that's all you have to do when finding out the spread using the interquartile range. Let's check out another one. Now this is a problem where we have an even number in between in total as well, so it might be a bit more difficult to find the quartiles, but not impossible. So let's do it. Let's first find Q2, our median, so we know the halfway point. So when you cross out these, you will eventually reach a number, you eventually cross out our 10 and our 12, so we know that our median will be somewhere between 12 here and 10 here. So what do? We add them together and divide them by 2. So 10 and 12 becomes 22. Divide 22 by 2 and you get our second quartile being, anyone remember? 11. So our median is 11. Now we know from that our first quartile will be amongst these numbers. So let's start crossing them out. Cross this one out. Da-da. Oh, well, if we cross these out, then there's nothing we can do. So we have a 5 and a 6. So what do we do to find our quartile? Exactly the same as the median. We add them together and divide them by 2. So 5 and 6 equals 11. You half 11 and you get 11 over 2 or 5.5 or 5.5. Same thing. Now let's look at Q3. So let's cross them out. Same problem. We have 16 and 18, cross them out, there wouldn't be anything, so we add them together and then halve it. So 16 and 18 equals 34. Half of 34 gets you 17. So what do we have to do? We do 17, subtract 5.5 or 5.5, and that gets us, anyone? 11.5 or 11.5 or 23 over 2. All exactly the same. And that's how you find the interquartile range. Find the median first, then find the median of the top half, the median of the bottom half, and subtract them. Sorted. So here's your challenge. I have 2 schools. I ran out of ideas. I have 2 schools and they are now competing in, let's go with one we've not done before. I don't know, history. History. We have 2 schools with their history results. Yeah, out of 15. There we go. Out of 15, they got 10 students and they wanted to compete. Now, from this, I want you to use the interquartile range to say which school has a more consistent result. Now, I've got the numbers, all fine, but I have not ordered them. So that's the first thing that you have to do. That's firstly a little clue. Now, remember how to find the quartiles, and I want you to find the median as well, so we know we're keeping on track. And using the interquartile range, which school does better? Good luck. I'll see you tomorrow, where we're going to do more quartiles, and we're going to actually be applying them and representing them in something. So you might have to go downstairs to the old creative zone. Right, so take care, guys. I'll see you tomorrow, and good luck with this.